Hey, Dave LeCounty with HeadGames Motorworks. Today we have Tyler Pappas here from Tyspeed. He had an engine failure with a spring kit that we put together, and the question was, did we install the spring height correctly? And I invited Tyler over here and I said, let's tape it together and we can show you how you can check spring height. Now this is something you guys can do at home. Check it out.
So yeah, at Lime Rock Park, we are racing the Grid Life GLTC series in our 1995 BMW M3, and we had an unusual valve train failure, which was the breakage of a valve spring retainer. So I'm here with Dave today to try to figure out and get to the bottom of why that failure occurred.
So what we're gonna do is I'm gonna teach Tyler how to install or how to measure all the spring height, the valve height, and how to get the math. And we're gonna use off-the-shelf parts. When I say this, I mean we are gonna take a generic spring kit. I'm not gonna mention whose spring kit it is because we're not throwing anybody under the bus. And we're gonna do a stock one, we're gonna do an aftermarket one, and we're gonna use a Harbor Freight caliper because that's what some of you guys might be using. And we're not gonna use specialty tools except for the spring height tester because, well, we need to use that. But in order to measure it, which is the most important thing for you guys, we are not going to use anything special because I want to make it relatable to you. So for comparison, we got the OEM and we got a dual spring. And to start it off, we also have the stock valve and we have the aftermarket valve. One is a single groove and one is a triple groove. We're going to go over all that. And we also have the OEM locator and the aftermarket locator. Tools for the job. You need a calculator, you're gonna need a razor blade, and you're gonna need a caliper. Harbor Freight, just laying around, and get that thing out from 7th grade. So you're also gonna need a pen and paper. You're gonna need to write some stuff down. This is the Buxton spring tester. It's a badass machine. Unfortunately, you guys won't have that, but you can at least measure it and go on the website of the spring manufacturer you're using and make sure you have the right height. Yeah. Now, I know a lot of guys are just gonna take the spring kit, they're gonna pull it out of the package and they're just gonna put it in their cylinder head, and that's absolutely what you don't wanna do. If you don't know these numbers, if you don't make sure that it matches whatever manufacturer you're getting your spring kit from, then you're gonna have a bad time. And then you'll likely blame the spring or you're gonna blame something else, but really it's the installation that matters. And I can tell you that sometimes manufacturers don't even know these numbers because they're off, and most shops don't test this. So they're gonna put a spring kit in it, they're just gonna pull it out because it's made for my car, that it should fit. But that's actually not the truth. First thing you guys should do is always zero your caliper. Zeroing it, make sure that you got your measurement correctly. So you can see, make sure it repeats, go back a couple times, zero it, make sure it goes back, we're good.
So we're gonna measure the stem height.
So first thing we're gonna do, we're gonna measure stem height. So you're gonna use the back side of the caliper and just stick it in there. And what you're doing is you're measuring it from the spring seat to the top of the valve there.
Okay. Got that?
Yep.
Okay.
So what we got here for a measurement?
Got 1.7050.
All right, so you're gonna write that down. So that's your first measurement. Second measurement is going to be your locator. So we're gonna do the OEM locator. You're just measuring the thickness of the locator, and we're at 69 thousandths. And now we're gonna measure your tip height. Now this is, you just put it together.
OEM triple groove.
Yep. So we're gonna OEM triple groove, we're gonna go over that in a minute here. There is a difference. So you put that in there, make sure it's tight.
Okay.
And then you use the razor blade. Now you're gonna take the razor blade and you're gonna zero just the end of it to the razor blade. Take your caliper, that's it right there. So we're 0. All right, so we're gonna go from the tip of the valve to the bottom of the retainer, because that's where your spring's gonna sit.
Make sure you keep it all nice and level.
Yep, and we're at 1985.
Okay.
All right.
So,
All right, so now we're ready to do some math. What you're gonna do is you're gonna take your 1705, subtract your locator, and you're gonna subtract the tip to the bottom of the retainer, and that gives us 1.437 spring installed height. Tyler's gonna put in here it's a little tricky, right? 1.437.
Okay.
Enter.
Okay.
And now we have 0.439 lift, which is 11.15, which is the cat cam that you're gonna be running. And we got the spring in here. He's gonna...
Click him on the Price is Right.
The price is right. Oh, you gotta do a little bit faster, Tyler.
There we go.
All right, so now we're 53 on the seat, 131 open, and we have a bind clearance of 83 thousandths with a spring rate of 178. Now I'm only gonna have Tyler check one side just because I want him to see how to just measure it and see what he's doing here. We don't have to measure the whole thing. That's not the point of this video. It's just to check the OEM versus the aftermarket and see what the differences are. All right, so round 2 is gonna be the aftermarket. So this is gonna be the single groove valve. He's gonna check it. And don't forget to zero the caliper because you did that with the, yeah, so this is a bone stock head. It's never been cut. Valve job's never been done.
0.0775, so 0785, okay. These are the single groove valves.
So single groove versus triple groove. The single groove is cool because it locks the valve basically. It stops the valve from turning so much. Whereas a triple groove, the valve turns a lot. Everything turns a lot. So you're, there's some theories that one works better than the other, but we've actually never seen a huge difference between either. So the Coyotes still use a triple groove. Although we do get rid of it in the Vipers, that's mostly because we use an aftermarket valve train, so we can't use it.
Any durability difference?
I've yet to see a durability issue.
Okay. 815. Okay.
All right, so the single spring is a beehive, and then you have the dual spring. Now the dual spring has obviously 2 springs, and it has a locator, and the locator, you can see, so this goes over the cylinder head. It has actually, the cylinder head has something that kind of mimics this, but you need to protect it with steel for the inner. Now in the math, we subtracted that piece, but you need that piece in order to, you want to initiate, you want to make sure that the inner spring has pressure. And reality is the retainer also has a provision for that. So the math needs to go with all of it, even though sometimes you wouldn't use all of it. But we're gonna put it in there. So this is the manufacturer's specifications. They measured at 10 millimeter, 1405 is the equivalent to the metric. And we're gonna put it in there and see what it does.
All right, and they're calling for 80 pounds at this spec, and also an open pressure of 195. So 80 and 195. So let's see what it does here as a complete assembly.
So we're at 120, 249, open at 10 millimeters, 82 thousandths away from coil bind, spring rate at 327. All right, so that does not match. What do you think we should do next?
I don't know, we're gonna have to find out, because when the math don't math, stuff usually breaks.
Yes. So full disclosure, I brought Tyler over here because A, he had a failure with our cylinder heads, and we take that very, very seriously. The second thing is that I have been telling this manufacturer that there was a problem with the math on this spring kit for quite some time, and basically they shrugged me off and told me that I was wrong. So I wanted a witness. I think a lot of people just shove stuff in, they don't measure it, and I know that we can't get the math to whatever they say is a spec. So Tyler is going to go over different variations of ways that they could possibly get the math. How can we get this measurement? How can we get these pressures that the manufacturer came up with? And if he came up with it, we learned something, and if he can't, maybe they learned something. So I'm going to say, let's first take away the retainer.
Okay.
Because the retainer to tip of the valve is something that we removed from the math.
And again, we're using the manufacturer supplied install height and spec lift.
Yes, this is not even our measurements because our measurements are different completely. So where are we at now?
All right, seat pressure 95, open pressure 218, and a bind clearance of 0.143.
All right, so Tyler's going to put in our measurements well, I should say Tyler's measurements, because I wanted him to be the witness that, so we're going to make sure that we do it the way we would do it. So you make sure you have your lift in there, and so your lift would be 11.15 millimeters. So we convert everything to inches because we are in America. All right, so just so you guys know, so when you want to take a measurement in metric and you want to switch it over to, what's American called? I don't remember. It's 11.15, and you're going to divide that by 25.4, and you're going to get 0.438.
The math teacher would be so disappointed in me right
Yeah.
now.
What is the name of? It's like not numerics. What
do
is
you
it?
mean? Oh, what's the American standard of
Is
measurement?
it Roman?
Roman numerals? No.
No. I don't know what it's called. It don't
Whatever.
matter.
We're not doing
Google
that.
that shit. You can figure that out. All right. So now what we're going to do is we're going to measure the spring. This is the educated guess part, right? So you're going to take the spring and the locator, and we're going to put that, even though we subtracted it from our math for the spring height, we do know that it's all going to go in the same package, which is below the retainer. That's the package you're going to be using. So we're going to use, we had 1.437, so which is what, 32 thousandths taller than the height, than the spec. And we're going to use our valve lift, which is 438 thousandths, which is 11.15 millimeters. And for all you metric guys, you just, you take 11.15, divide that by 25.4, and you get your English. So we're going to check this and see what that does.
Right. Successful test.
Look at that. So now we're at 84 on the seat, 224 open, and we're 129 thousandths away from coil bind with a spring rate of 318.
Getting closer. I mean, they did specify 80 at their lift, though, not ours, and 195 at their lift, not ours.
Well, it's going to have more open pressure because of the lift.
Got it.
All right, so it's a couple days later, and Tyler's back. He had some revelations. What happened? What happened to you?
Well, I reached out to Martin at SuperTech, which we can say the name now thanks to the collaboration that's taken place between us all, and basically said, listen, Martin, what we're getting here is not matching the specification. Dave had reached out many times prior to try to get to the bottom of the solution. Apparently it took a little bit of good looks and charm to get Martin to respond.
The big dick.
He finally reached back out, did some measurements on his own, and we came to the agreement that we were not in alignment with what we were seeing, reading, and actually seeing in real life. So, Dave, what was the result of that conversation with Martin?
Well, Martin figured out, Martin from SuperTech, so they have the same spring tester that we do, and he said there's no way that the pressures are correct because he put the same spring in his tester and it was wrong. Well, at least our numbers were wrong. And what happened there is I needed to calibrate our spring tester. So I went out, as soon as he said it, I was like, no way, I just got this thing back and from Buxton, and how can that be, right? But it was actually wrong. So we were able to calibrate our spring tester and brought Tyler back now. And so talking to So when I'm talking to SuperTech, they admitted that they had the math wrong. So they used a different cylinder head. They didn't use this cylinder head, but they said it fits this cylinder head. So now we couldn't get the math, the pressures and everything else right, and they needed to supply a different locator, which is what Tyler was able to get. And Tyler, so we can show how different thicknesses they are and do some math. All right, so this is the old locator. You can see here it's 75 thousandths thick. And then the new one should be right around 117. So it's actually like 122. It depends. So a caliper,
Oh, there we go.
caliper is almost like a feeler, right? So if you push your thumb, you can make it tighter. And this is why if you ever really need to know something, a
There we go.
micrometer is the deal. There you go. See, 122. So what we're gonna do is now I still couldn't get completely. I couldn't get the math that they had for an install height. So what we did was we just measured what we have currently. Now the stem height, or the stem protrusion, which is the valve sticking through the cylinder head to, you measure it from the spring pocket to the tip of the valve. We are, I think, 30 thousandths off from their measurement, and which is almost a millimeter. So a millimeter is 40 thousandths. And we decided that even though, so the head's stock, and when we valve job it, we're gonna probably take 10 away from that because it's gonna sink to valve 10. And either way, we're close enough for what we need to do here. And the other problem is, to be honest with you, it's just the way that we're measuring it. So because we're measuring it with a caliper, because I wanna measure it like you guys would be able to measure it, and we're not doing it with a precision tool. So we might be 10 thousandths off there.
A little variance.
Yeah, there might be like a little variance there, but which is okay because we don't want to. I want to keep it like you guys would be able to do it, and we're gonna put the whole spring kit in together because you need the retainer, you need the locator to compress the spring. So what we're gonna do is we're gonna subtract the tip of the valve, just the tip of the valve, from the retainer. And we subtract that from our stem height, and then we're going to use the entire package together, and we're at like 1,550 for that.
All right, so we've now entered some of the data into the tester. Dave's gone ahead and typed in our install height. Now this is not the install height as recommended by the manufacturer, but the install height that we have physically measured ourselves here with this cylinder head and the components in front of us. I would also like to mention that our valve lift as entered here is the valve lift of the camshaft that I will personally be using on my cylinder head. This has been converted from metric to imperial for all those watching at home in the UK and America.
And not American, it's imperial. I couldn't think of that word.
Imperial, I know, that was a tough one. So anyway, slightly higher lift on this cam than factory, 11.15 millimeters. That translates to 0.438. So we're going to demonstrate the difference now between the original locator that is supplied with the kit versus the thicker locator that has now been supplied to us and will be supplied going forward.
So what we're going to do is we're going to measure it from the highest point, which is right here, or this high point right here, and basically you're subtracting the tip of the valve from this, so we can put it all in the spring tester all in one shot.
All right, so let's start first here. This is the retainer, the spring locator that was originally supplied with this kit for the last 10 years. This is the thinner of the two. We're gonna put that on the tester, and we're gonna let it run. What do we got?
76 pounds in the seat, 211 open, 186 from bind with a 306 spring kit, spring rate. All right, so let's put the other locator in there.
Okay. Now this is supposedly an improvement.
Now the spec is more than that.
Yeah.
So that's where he wanted it. He wanted it tighter. He wanted it.
Success.
84 pounds on the seat, 221 open. It looks a lot better. It's much closer to spec. And now we have something we can install.
So Dave, tell me, I'm just know enough to be dangerous. Why is this an improvement for this kit in this package?
Well, it's going to get us closer to coil bind. And whenever we're closer to coil bind, we are going to have the spring is basically going to use itself as a cushion, but it also won't get excited. So if you think of like a slinky, the farther away you get the spring from each other, the center got a little wobbly. And it also wasn't at spec. So like when they make these springs, they have to be at a certain frequency, and they want to be at a certain height, and they want to be at a certain pressure. And if you don't have all that, then the spring gets excited. And that is why it's super important to always measure stuff and not just throw stuff in. And too tight, you know it. Too loose, everybody's going to know it, because it could come apart because it's not at the right height that they designed the spring at. Now, don't get me wrong, if you're too tight, you're going to increase the stress, and it could break it. It could break the spring. We're not anywhere near that, but I'm saying that there is two sides of that, and I would just much rather be tighter than loose.
Got it. And it should be worth mentioning too that this kit has always worked well in this application without issue, from what we know and what we've heard from SuperTech. But the scrutiny that we put to this particular application has caused them to revise this and hopefully better the kit going forward.
They've actually had this kit since 2006 with no real, I mean, nobody's mentioned that they've had any kind of problems.
I was in 8th grade and was running track and field. I didn't even know what a car was yet.
Oh, well, I was in my 5th year of HeadGames. So I was setting world records with NHRA Sport Compact Racing Series. And so we're at different points of our life, but the kit's been around for a very long time. We've actually been using this kit for 5 years and have had no issues until Tyler. The only issue I've had is that I never could get the numbers that they advertised, so I didn't know. We would just install it. We'd never really.
Yeah, but you were installing it to the point where you guys thought it was right. It was safe. Everyone was comfortable with it.
Yeah.
But now we're improved, and everybody is collectively on the same page.
Yeah.
User, machinist, and supplier of the parts. So
yeah.
that's a happy
Thankfully, SuperTech hit this with no ego. Now, I deal with a lot of different manufacturers, and we've helped improve a lot of different manufacturers' parts because we measure everything and of course our experience. And there are certain manufacturers that walk around like their balls are too big, and that I could never be able to tell them something that they already know, or they can't do better. But SuperTech didn't do that here. SuperTech said, hey, check your spring tester because that's wrong, which they were right. And they were like, hey, our numbers are actually wrong, and thank you for helping us correct it. And that collaboration between the three of us really just made the whole thing better for everybody. And it all starts from just having a conversation, because when you have a failure, Tyler could have obviously just went on the internet and said screw HeadGames, and and then it turns into.
I would never.
You would never, but yeah, but if you did, right, then nothing gets solved. You need to build a bridge versus building a moat. Yeah. And we built a bridge here, I made him come over here, I made him measure it, I made him see that I can't find these numbers, he couldn't find the numbers, and then he reached out to SuperTech and made everything work much better. And I think we've kind of changed what is going on here. So I really appreciate everything you've done, and I appreciate everything that SuperTech has done. And actually that's why they were cool with us talking about them in this video. They have nothing to hide because they're making it better. And it's not like failures of this thing have been rampant for all these years and then we solved it.
But we're racing stuff, now we get to push a little harder, worry a little less, and I think I made 2 new friends out of it.
Yeah, it's much better. Yeah, you didn't make a friend here, though.
Oh, sorry.
I'm pissed off at that guy.
Maybe Martin still likes me.
Big thing. Anyway. So that's going to do it for us today. Be sure to like, subscribe, comment below. If you have anything you want to see, be sure to comment below. And you can also check out Tyler. Tyler's got a YouTube and Instagram.
Instagram at Tyspeed, yeah. Do all things BMW. So we'll be doing some more BMW stuff here in the future, I hope.
Cool. Toodles.
Later.
HeadGames!